Hello friends, welcome to the first episode of System Design Fundamentals, and as promised we are going to start with the very basic and we are going to take things forward, understand more complex things down the line. So let's start with a very basic problem that we are trying to solve over here. So let's take a real-time scenario wherein let's say I have around 10k books and I wanted to sell them. I don't want to use any e-commerce website to sell them. Since I am a developer, I thought of building a website wherein customers can come, search for the book, add to the cart, do the billing, view the books, and things like that. And later, if possible, I'm going to leverage this website and integrate with some other site, make it large. So that's what I thought, and I started creating a web application. So what do I need in order to create a web application? So I need some pages, HTML kind of pages. So let's say I'm going to develop a very basic website. So I have a welcome page, let's call it index. Then I have a search page. From the search, you can view your books that you want to choose from the search result. You can click on it and then finally add it to the cart, and then you should be able to view the cart, right? So I need a page for the cart and I need a page wherein you do a final checkout. So let's call it billing. So I created all these pages, and for each of the pages, I need to have some modules. More like backend, right? So I will be creating some of the module. So let's say I'm creating one module for search, one for books, one for cart, and the other for billing. Now I have 10,000 books, and so being the owner of the website, I should be able to add books, and when the books are sold, I should be able to delete them. And of course, when I am inserting so many books manually, I should have a provision to update it. And then of course, at the end, we need to have a view, right? So this add, delete, update, these are going to be the admin things. Only I should be able to do it, and users, normal user should come and only view it, right? And from the view, you can add it to the cart and finally go out for a billing, right? So you can write this kind of application using say PHP, Java, .NET, Python, JS. There could be many languages. We are not going into that. So the basic thing is that I'll be creating these pages and I'll have this module and everything is good to go. So now once I have built this application, what I'll be doing is I'll be deploying this. So let's say first I'll be building this. After the build, I would get something like a jar. If it is a Java application, it could be a DLL or scripts as well, depending on the choice of your language. And then I should be able to deploy it in my local host. Right? So localhost is nothing but a server running on your local machine on this port by default, :8080. And from this, what else we need is probably we are going to do a search and all. So we need a database. So we are not going to go into details what kind of database and all. In the subsequent episodes, we'll be talking about all those things. And also we need a file storage. So what do we store in the file? I store all the thumbnails, the images, and everything of the book, right? So when you view a book, you should be able to see the front, back, content, cover, many things you can store, right? So now once we are tested, now this application is ready. So we are done with our testing, and let's say this is tested okay. And the next part is we need to deploy this application into a server. So we need a server and we need a domain. So domain is nothing but your name of the website. So let's say we call it books.com. And the third thing that we need is an app that we want to deploy. That is our jar or DLL or whatever file it might be, or the scripts or whatever you have, you need to have it in place. So the server is nothing but a PC in a rack, and we are going to talk more about rack, server, data center, and everything. So just for now, it's a PC running on somewhere on the cloud. And what we have on a PC, we have RAM, we have a processor, and we have some disk. There are many parts, but these are the three important things that we are going to talk about. So let's say this is a server, and every server has an IP address. Let's say the IP of the server is this. And now let's add the RAM, hard disk, and the processor to the server. So let's say my budget is not high, so it's all matter of money. So I go for a i3 processor. I have installed some 32 GB of RAM, and let's say I have 500 GB of hard disk space. So this is what I started with, right? So now I have the server, I have an IP to my server, I have some storage, some RAM, and some processing power installed on the server. The next thing that we need is our database. So as we talked over here that we need a database, right? So we need to install a database over here. This is our database over here, and this database would be accessing some of your memories from the hard disk, some RAM, some processing power in order to perform search and queries. Hard disk space for storage, it's using some of the RAM for caching and other activities, and it is also using some of the processing power from our processor over here. The next thing that we need to do is deploy our jar. So now we have deployed our jar inside the server, and this jar over here is also going to access some of the CPU, the RAM and the storage. And this jar is your application over here, right? And it is also going to make use of the database, right? So it's going to use your database. So this is how it looks at the end, right? Your server is having the database. So let's put the name over here. So this is your database. The database is using your hard disk, your RAM, your processor, so is your jar, and the jar is also using the database to make the queries to get the data, right? So we are going to buy some domain, and once you buy the domain, it will have something like a lookup table, you can say. We'll talk about it in more details later, not at this point of time, but just to give you a overview of what it does is, suppose I have books.com, and it will have a mapping to the IP address of the same. Be something like this. When you type books.com, it goes to the DNS, and the DNS is resolved to the IP address of your server, and the request is sent to your server, right? So let's put a picture over here. So this is your end user. The end user makes a request from the browser. What happens is the request goes to the DNS. DNS does a lookup, and based on the same, the DNS sends it to the server. So it will happen something like this, right? And your request will be served, and your application is ready, and it is being consumed by the user. The user is coming to your site, making a purchase, and your business is doing good, right? So let's say I have added 10K books, right, at this moment. So after a month of doing a lot of ACOs and all, we are going to talk about those things as well. So let's say you found that there are nearly 1,000 requests that is coming per minute for searching your books. And out of this 1,000 requests, there are 1,000 results that's loaded up on the UI. People are viewing almost 800 books. So 800 requests is coming per minute for you. And books are getting added to cart. So let's say a lesser number of requests here. Right, so your searches will be more compared to your view. Your views will be more compared to what's being added to the cart, and what finally gets billed is even lesser, right? That's how the ratio works out. So currently, this is what you are serving every minute, right? So you have 1800 plus 50 plus nearly 1855 requests you are serving per minute. With this, things started looking fine for you. The business is going good, and you thought of adding more books to your website so that you can boost your business, right? And before doing so, you thought of doing some check on your service or the server that you have acquired, right? We have HDD, the hard disk space. You found out that you have already used 380 GB storing data, the databases data, and many other things, right? And you are processing so much of request. Your RAM is also 23 GB is used. And you can also see that your processor is having an average usage of around 70%. This doesn't look good, right? These numbers are pretty high, right? We have just 120 GB of space remaining. We have just 9 GB of RAM remaining, right? And we have 30% of your CPU. So CPU is, right, it's working too much, right? So as you start adding the books, you found that your requests are now getting increased. So you have nearly 2,000 requests every minute coming in, right? And you have around 1,800 books that's being viewed. People can share links also of your books, not only from the search, right? And people are adding more to their cart. Your business is growing, and you have around 15 requests per minute on your billing. So this number is pretty much high. It's close to now 4K requests per minute you're dealing with. So as you try to add these books, what you found is that your storage is not enough. When the more requests start flowing in, you found that your RAM usage is also going up, right? Your hard disk usage going up, your request processing is increasing, so is your CPU usage. So one way to handle is that I have a machine with me. We have some storage, we have some processing power. So you thought of giving a boost to the service that you have. So what you did is you bought another hard disk and you have put it over here. So another 500 GB you have added. You have increased your RAM. You have now 64 GB of RAM. And you have upgraded your i3 to, let's say, i7 with more processing power. And things started looking nice now. So what you have basically done is you have scaled your server to handle more requests. So this type of scaling is called vertical scaling. So basically vertical scaling means keep your existing infrastructure but add more computing power to it. So your existing code does not need to change. You simply need to run the same code on the same machine but with a better specs, right? So we have better specs now. We have 64 GB of RAM, we have 1 TB of hard disk, we have i7 processor. So basically what you are doing is you are increasing the capacity of the single machine that you had. So this is called vertical scaling. Vertical scaling allows the data or your application to live on a single machine, and the scaling spreads the load through your CPU and RAM. So since you have more RAM and more processing power, you are distributing or you are scaling in that terms. So this is one basic concept over here, which is your vertical scaling. So our machine was under provisioned and we have provisioned it enough now. But if we want to scale even further, then we need to think about it. If you see here, we are now dealing with 4000 requests per minute, right? If I break this down, let's say each of the requests is taking 1 second. Just for sake of simplicity, it might take more. So I have 4000 requests and I am dealing with almost 66 requests. So if it takes more than 1 second, it goes to 133. If it takes 3 seconds, it goes to around 200, right? So we have a bottleneck over here. So how much a load a server can take? If you take Tomcat as an example, you can see that the default installation of Tomcat set the maximum number of request servicing threads at 200. Effectively, this means that the system can handle a maximum of 200 simultaneous HTTP requests at one given point of time, beyond which your request will not be accepted anymore. Your thread pool will be exhausted, kind of, right? So we have a bottleneck here. We cannot just handle the request like this, right? So if I wanted to scale more, so let's say if I wanted to add more books over here and take it to an even bigger scale, let's say I am adding another 50k books over here. Here I have added some 50k, right? And definitely I'll be doing publicity of my website. So this will go up to 5000 requests per minute, right? If you take example of sites like Amazon and all, they have more than this number of requests, right? How many views happens, right? Throughout the world, people are viewing it, right? So let's take some really big numbers over here. So let's say 3800 requests per minute. Let's say 1000 books are getting added to the cart per minute and almost 500 request is coming over here. So with that, we have a pretty bigger number, close to around 10k maybe, right? Now there is no point or there is no scope for me to have a vertical scaling in place, right? That's when the horizontal scaling comes into picture. So what does it mean? It basically means I am going to add this new server over here and let's assign some IP to it. And I have just added another server to my system, which is my server 2 over here. And with that, my mapping also needs to be updated. So you can have multiple mapping. We'll talk about load balancing later. I am not going into the topic of load balancing at this point of time. So now you have multiple mappings for a particular domain. It's quite natural to have more than one mapping. So let's take a look. So here is a MX lookup. So here we are at DNS lookup site. So you can just do a lookup of the DNS. And we have done it for Amazon.com, and you can see that there are multiple IPs that's associated with the single domain, right? So this is the DNS record. Let's check for adobe.com. So you can see that there are 2 IP address you can see over here. So here is for Microsoft. You can see that there are so many IP addresses over here for Microsoft.com, right? We can also have our multiple things. What will happen is you will have another line coming out from here, and which will be pointing to your new server over here, which is your server 2, right? Now with this, there is a problem, right? We can see a problem upfront that we have our system and we have spent a lot of cost, right? The cost is fine for now. Let's ignore that. But you see that you have this database over here and you have this database over here. The database is not centralized, right? So any data that's stored over here will not have a record over here. So if your search lands over here in this IP or this server, so you're going to get the data from here only. But you might have more records over here, right? So what we need to do is we have to segregate them out. So let's take them out. So we have a completely separate database server. So this database server is having the database, it is using the processor, it's using the storage, and it's using the RAM. It has its own everything, right? Now we can remove this database from here. We don't need this. Right? So the database part is segregated completely. And what this jar can do is now it can talk to this database server directly. Right? And similarly for this guy also, I don't need this database server. So we are good over here. So this server is also directly talking to the database, right? So all this database activity is taking place in separation in a completely different server. Now if you look at this, so we are storing the file over here, but this file is again becoming local over here, the thumbnail images and everything that we are storing, right? And that is not going to help us. So let's take them out as well. So we can just have a separate file server in some different IP and we can just use that. So let's put a file server over here and let's give him a IP 10.185.63.22, whatever it is. So we don't need to store them locally over here anymore. So what this application can do is now you can directly talk to your file server for storing the files. So they directly can talk to this file server who will take care of storing the file. Now with this, what we can do is probably we don't need such a high processor over here. So with this, we might not need a i7 processor. We can have smaller i3 processors that can take care of things, right? So let's move them back to i3 and we don't need so high storage also. We are not storing anything anymore over here. So we can have some bare minimum, let's say 100 GB of storage. Depends, we might not need 100 GB even, right? And we also don't need so much of RAM, right? We can get rid of it because previously it was all shared. So you can see over here that this has become so lightweight, right? And also we have prevented something. We have prevented a single point of failure. So previously, if you notice that we have only one single server and it was storing everything, it was holding everything, right? What if it goes down? So everything goes down with that, right? Your request fails, your user gets impacted, they come to your site, they see a page not found or some error, internal server error. That's not going to leave a very good taste, right? Now with this, what we have is we have multiple servers, right? Even if one of the server goes down, the other can come to the rescue, right? This kind of scaling wherein we are just replicating the entire architecture is called your horizontal scaling. You can easily add more machines to it, right? So you can just go ahead and create another server over here, which is your server 3. So you can easily introduce new servers and you can just update your DNS mapping and you are good to go. Now just understand one part over here. We have kept the database in isolation, right? It's not a part of any of the service anymore. So with this, if a service goes down, you are not impacted, right? Though this database part is still a single point of failure. So if this server goes down, so if you have an error over here, all the system stops working, right? So you should have duplication or replication everywhere. So there should not be any single point of failure. We are going to see those things in more details. For now, what we have seen that if a service goes down, you are not impacted. So you are still good. So this kind of scaling is called a horizontal scaling. And another benefit you can see over here that your load is being now distributed, right? So we have say 10,000 requests. So each of my servers are handling a partial load, right? 1/3 of the load is going over here, 1/3 is going over here, and the remaining 1/3 is going over here. So we can increase the number of instances to control the amount of load each server is handling. We are going to talk about it in much more details when we discuss about load balancing. For now, you can understand that if you have n number of machines, you'll have 1 by n of the load in each of the machine, right? If you have two machines, for example, if you have two servers and you have 4K requests, then ideally 2K of request is handled by each one of the server. So that is one of the big advantage of having a system like this. So we have talked about two of the scaling types over here. So the first one is your vertical scaling. The second one is your horizontal scaling. So just to summarize, what is the difference between the two? Vertical scaling means adding more resource to a single system and adding more computational power in terms of CPU, RAM or disk to cope up with an increased workload or increased number of requests. Whereas horizontal scaling means adding more machine to the resource pool than simply adding resources by scaling it vertically, right? Here we are not empowering the machines, right? In horizontal scaling, we are not empowering the machines, but we are adding more into the workforce. In a vertical scaling, we are empowering with more RAM, more storage, more processing power and everything, right? So now this both vertical and horizontal scaling that we have talked about, both can be performed automatically, also known as auto scaling. So we are going to talk in more details in the upcoming episodes, so wherein we are going to see how the auto scaling works. So with that, we have talked about horizontal scaling, vertical scaling, and also we have seen that a single point of failure has to be avoided at every point of time. So we are going to talk about it in more details in the upcoming videos of the series. So here we have discussed about a scenario wherein the entire books.com is managed by books.com itself. There was no outside integration and we just had our endpoints secured within ourselves. It was not exposed to the rest of the world. So in the next episode, we are going to have it integrated with multiple e-commerce website, right? So they want to publish directly their books onto my website. So since we are popular now, and we also wanted to publish some of our books to their website and sell it through them. So in the next episode, we'll be talking about how to expose this REST endpoints. So in the next episode, we are going to talk about exposing this RESTful web APIs to other websites, the mechanism, how we can use to authenticate them. So with that, we'll finish the first episode over here. So in this episode, we have talked about horizontal and vertical scaling. And also one important point to keep in mind all the time, and I'll also be talking about them almost all the time, that is single point of failure. So we need to avoid this at every cost. We should not have a single point of failure. So here we saw that this was a single point of failure. So this guy goes down, everything goes down. This guy goes down, all the thumbnail goes down, right? This gives a very bad experience to the user. So slowly we are going to talk about all those things. We'll talk about redundancy, we'll talk about replication. So with that, we'll end this video over here. Since this is the first episode, I would like to hear back from you guys that did you like the way we started this, or is there any way we can make this better? So do let me know about all those things, and I'll try to incorporate those things from the next video onwards. So do let me know your thoughts. That's very important to have us all in sync and have a good understanding. So I thought horizontal scaling and vertical scaling is one of the good area to start with, to have the understanding why we need a distributed system, right? Why we need to have redundancy, replication, how to do that. And definitely we'll revisit this. This was at very high level. We are going to try those things hands-on when we go into the containerization part with Docker sometime down the line. So bye-bye, take care and see you soon again with the next episode.